experiences. Before we begin with the formal lecture, I would request Dr. Vijay Mathur to kindly felicitate Dr. Rajvir Singh with a bouquet. I would now request Dr. Kalaivani to kindly present a plaque. I would request Dr. Maruf, Head of Department Biostatistics, to kindly present a plaque of AIIMS to Dr. Rajvir Singh. Dr. Rajvir Singh is a top-ranked postgraduate in mathematics from Agra University, and then he completed his PhD from AIIMS, New Delhi in biostatistics. Having worked with medical fraternity over 25 years, he has been exposed to a wide variety of statistical techniques. He has been actively involved in teaching research methodology and biostatistics courses to medical residents, research fellows, and guided more than 10 PhD students as guide or co-guide. He has inculcated the culture of research at Hamad Medical Corporation, a premier institute of super specialties in Qatar. He has more than 500 peer-reviewed publications to his credit, with more than 12,000, almost 13,000 citations and an H index of 59. 97% percentile research is positioned in research fraternity of the world. He has completed 8 national research priority projects worth $7.5 million. He has modernized biostatistical techniques with internal validation of time-varying, time-dependent Cox regression model through bootstrap resampling technique, digitized unipolar and bipolar Likert scales of qualitative data to make it on par with quantitative data. He has developed and validated research questionnaires. He has also spiritual work to his credit in the form of Saras Gita with Gita Gyanopdesh in Hindi couplets for 18 chapters, Srimad Bhagavad Gita, a book which was published by Brahma Printing Press, then Dharma versus Religion, which was published by Notion Press. I welcome you, Dr. Rajvir Singh, please. Yes, sir, please.
Very good afternoon. I just buzzed in between to tell you a few things about Dr. Rajvir. Dr. Rajvir was with us in AIIMS long back, about 20 years back. We as a postgraduate student and then as a research officer, we used to interact a lot with him. He was very popular amongst us, and not only as a biostatistician, but with this in-depth knowledge of Sanskrit and Veds and all those gyan. And I think he has used all those in his biostats to give us a bigger insight today. So welcome, Dr. Rajvir.
Thank you. Thank you, Dr. Mathur and Dr. Pooja. I would like to thank Professor M. Srinivas, Director AIIMS, for the allowing me to give this talk, and for you also, the valuable time I am taking from you. So thank you very much once again, and let us start with the topic. Data and statistical errors in medical research. You know, for a new researcher, data and statistical error, if you understand well, then you can conduct your research very smoothly. So the focus will be on data and statistical errors. First, I will start with the data. What is data and how to deal with it, and then what is the statistical errors, so which will be benefit you. Now, there are quote from Mark Twain, lies, damn lies, and statistics. Do you agree? All are agree with this? But I am not. You know, if I am a statistician and if I am given a task of some operation in the operation theater because the surgeon is not available, and if I perform the surgery, then what will happen? Result will be 0, patient may die. If the same thing is done by the surgeon, the expert for the particular the operation, he will get the 100% success and the patient will also alive. So here it is same. You know, the statistic is tool, lie is the tool, not the person. So Mark Twain says that statistic is the lie. No, it is the person who used it. So it is not individual, it is instrument. Instrument is, if you are using properly, then definitely you will get good result from the statistics. So I am with this world is full of statistics. Since morning to evening, what you do? You are generating data. Getting up early in the morning, taking tea, preparing yourself for the office. At what time you have to reach at the office, you have to work and then finish the work and then house drudgery. So many things you are generating data. And you know nowadays AI, within a 2 or 3 years, if data is collected on you, we can prepare artificial intelligence and say that you are going to do at this time next day. So statistic world is full of statistics. Nowhere in history or wherever you will find the statistics. I declare no conflict of interest for this topic. So let us start with the topic. What is research? Research is a systematic and scientific way of obtaining data for solving healthcare problems. Now you are seeing here the systematic, scientific and data. There are 3 important ingredients for the research. So we will discuss a little bit about that. So you will grasp what is the research. So what is systematic process of research? First, we plan. In planning what we do? We prepare the topic. The final formula you must be remember. You have to see the review of literature and find out whether this topic, what you are preparing is final, feasible, interesting, novel, ethical and relevance. Okay. So if your topic is final, formula is appropriate, discuss with your mentor, prepare 1 paragraph of that, because there is no paucity of the research in the world. Today you are conducting one research and concluded it, the answer of that research will give you another research question for you. So there is no paucity, but you have to be on the job systematically. So once you plan the research topic, what is the next step for that? In which way you are going to complete research design. If topic is new, then you are going to describe it, descriptive design. Describe the each and every characteristic of that, and you can publish it also because it is new. Once you describe the particular disease or new disease, then what you next step will be, what is the burden of that disease? I mean prevalence study. What is the prevalence of a particular disease in the community? Okay, so then you will go for the cross-sectional design. Okay, and once you find out the prevalence of a particular disease and it is not rare, it is common, then what you will do? You will say that why it is happening. You will go for the case control study. Okay, so you will know what is the exposure for this particular disease. Once you know the exposure of the particular disease, then you will find why it is the disease, when disease will happen by this exposure. You will follow that exposure, okay, the cohort design. then you will find out, yes, this exposure is the risk factor for the particular disease. Once you decided this is the risk factor, then what you will do? You will treat that. So clinical trial. So this is the research question, the circle. Okay. So whatever the topic you have decided, decide in such a way that it's which one is the suitable research design for you. If you are not doing the suitable research design for the particular topic, you have decided you are not going, the result will be biased. Nowhere you will get the result properly. Once you decided the research design, you have planned also. Now what the next? Sampling. Sampling from where the population, which population you are going to select for your topic, which is the suitable population for sample. You will prepare the sample frame. And once you prepare the sample frame, then how much sample size is required? Appropriate sample size. That is the next step. If it is not appropriate, then what will happen? You are going to underestimate the problem. Or if it is more, the resources will be required more, then time will be more, and the money will be also spent more. So if it is more, then overestimating the problem also sometimes it happens. So appropriate sample size is required according to research design. Then data collection, which is very important. By topic you have decided what type of data or what is the variable you are going to collect. You have to go for the review of literature, what people have collected for that. And by experience also you can add. So data collection, what are the variables you are going to collect and which way you are going to measure them. The best method for the measurement of the variable is required. So that you have to keep in the mind. Then data analysis, that is you don't have to bother. Dr. Kalayani and Dr. Maruf is there for you. Okay? Because nobody can be expert, but they can guide you well if you want to learn also. The result, interpretation, conclusion, and then publication. This is the system for research, the research process. If you are adhering this, definitely you are going to get the good results from your research. Now, second is scientific method. You remember the story of Bell and Hill in 1960, UK surgeons. They were operating lung carcinoma cases. And they found that most of them are smokers. They generated the hypothesis that smoking may be associated with the lung carcinoma. And they collected the case control study, those who are having lung carcinoma, those who are not having lung carcinoma, how many are smokers in that, how many are smokers in other group. And they found that the smokers are more in lung carcinoma cases group. And they prepared the theory for that. And theory became knowledge when each and every region, the researcher were doing the same, conducting the same research, and they got the same result. So theory becomes knowledge. And now you can see that very well, smoking is injurious for the health. Okay. Now the third factor which is important, we are going to talk, the statistic part, is the data and the statistics. So what is data? See, if I collect the information, the variables, characteristic like age, gender, smoking, this and this of this group, and summarize it. What is the mean age of this group? The whole people, this becomes information. If I summarize the male and female ratio, this is the information. And on this information, if I apply the advanced statistical tools, then it becomes fact. And fact becomes knowledge. Okay? Smoking is injurious for the health. You can make out from that. So data is the very important, and now I am going to discuss a little bit more about the data. Before starting the data, you just know about the variable. Variable means vary plus able to vary. A characteristic able to change individual to individual is called variable. So for example, age is the variable here. 56, 55, 23, 24, it is changing. So age is variable. Length in cm of that person or individual is variable. Gender is the variable. Family history is the variable. Okay. So they are the characteristic. The family history is the characteristic where it is changing. Yes and no, something like that. Individual to individual. That is called variable. And collection of the characteristics for a particular individual. Like age is 55, length is 170.5, gender is 1, male, family history no smoking, depression level 2, and lung carcinoma no. So these are the characteristics for an individual. Then it calls record. And collection of record is called data. Okay, it is clear? Because it should be clear for you, once you are going for the analysis of your data, you should know all these things, which is very important for a researcher to understand, and what type of errors it may come into your research, that you should know beforehand. So now, what is the characteristic of a variable and level of measurement? A variable is measured by the names. It is called nominal. Like word A, word B, word C. These are the name for a word. So word is a variable. This is nominal variable. So distinctiveness is there. In a variable, then it is nominal. If the distinctiveness and order is also there, then it is called ordinal variable. For example, this is stage 1, stage 2, stage 3. It is order also. Mild, moderate, severe, by name and by order. So ordinal variable. And internal variable, if the consecutive numbers have the equal difference, equal distance, then it is called interval variable. So like 35, age is 35, maybe 36, maybe 37, but difference in consecutive numbers is 1, equal. So a variable has the distinctiveness, order, and equal interval. Then it is called interval variable. So you know once nominal, then ordinal, then interval, the stage is increasing. The property is increasing. The 3 property, 1 property, and if you add the 0 in that, it becomes continuous variable or scale variable. If we categorize them, for example, the ratio variable, scale variable, or continuous variable, or interval variable, no, ratio variable, which includes the 0. So it has the 4 quality: nominal, ordinal, interval, and 0. Then it becomes continuous variable, ratio variable, sometimes scale variable, or sometimes interval variable also we call. But all the way we call continuous variable. This. Now, so this was about the data. And you should know what are the data, what are the variables, and how to, if you are going for to the statistician to discuss your research, then how you are going to interact. These are you can say those are the variables having nominal and ordinal category characteristic. They are categorical variable. Interval and ratio, they are continuous variable. Now, statistical errors. So just now it was little bit about the data. You know, everywhere you will see data, variable, this and this, but you should know what is the depth inside, so that you can interact with your research properly. There are methods, statistical methods. If the categorical data is there, the statistical methods are different. If it is continuous data, the statisticals are different. So you should know about that. Now, statistical error, which is very important in day-to-day life. When you want to conduct your study smoothly, definitely you should be worried or aware about the statistical errors. Errors occur during planning of research, designing of research, measuring of variables, sampling and data collection, calculation of sample size, result interpretation and analysis of data. So everywhere in the process of research, they can occur. But you can very much minimize them if you are aware of that. So there are two types of statistical errors: decision errors and sample error. Now I will tell you about the story. All statistical things, decision error and sample error will include in that. And then I will ask you at the end of the topic, so what are they? Okay, I will tell you one story. Hindi is okay? Okay. एक राजा था और उसकी एक बहुत सुंदर रानी थी। दो उसके बॉडीगार्ड थे, बंटी और बबली। राजा बहुत ही शौकीन मिजाज का आदमी था, सब कुछ ठीक चल रहा था, तो उसने सोचा कि अब मैं रिसर्च करना भी सीखता हूं। वो चला गया, दूसरे दिन उसने चालू कर दिया, उस पर गया शिकार पर, और वही उसको आइडिया आ गया कि भाई I should do the research on the relationship between the bodyguards, Bunty or Bubbly, and the queen. This was the idea. And शिकार पर चला गया वो, वहीं जाके डेटा कलेक्ट करने लग गया। जो मिले वो बॉडीगार्ड भी साथ थे, तो बॉडीगार्डों को कहता था तुम थोड़ा अलग हट जाओ। कोई भी मिलता है कि देखो भाई ऐसा है, मैं रिसर्च कर रहा हूँ, तुम्हारा नाम क्या है, तुम्हारी एज क्या है, तुम्हारा ये है क्या है, सब कुछ इंफॉर्मेशन कलेक्ट करने के बाद पूछते हैं, ये बताओ रानी के साथ किसका संबंध हो सकता है। या तो क्योंकि जो बंटी था वो थोड़ा स्मार्ट था, सुंदर भी था, और बबली तो ऐसा ही था, लेकिन गुंडा भी था। वो गुंडागर्दी वाला था कि ये ऐसे ऐसे लोग हैं। अब तुम देखो तो लोग देखते थे कि हाँ राजा कह रहा है तो ये सुंदर वाला ही होगा, यही है, इसी से संबंध हो सकते हैं उसके रानी के। ठीक है, रिकॉर्ड किया राजा ने। पूछते पूछते वो शिकार करने जा रहा है, वहां कर रहा है, महल में नहीं पूछ रहा वो किसी से, जो किसी बात भी करते हो कि नहीं, बस वही जहां उसकी मर्जी आई वहां, क्योंकि वो तो राजा है। कुछ महल में भी पूछा, ऐसे करके बहुत सारा डाटा इकट्ठा कर लिया उसने। डाटा इकट्ठा करने के बाद एनालिसिस कर दिया। एनालिसिस में क्या हुआ, बंटी बहुत सुंदर तो था लेकिन बहुत ही इनोसेंट था, और वो बदमाश किस्म का आदमी था लेकिन सुंदर भी नहीं था। तो रिसर्च में आया ये कल्प्रिट है ना, ये बंटी है। तो राजा ने कहा हाँ इससे ही संबंध है, क्योंकि एनालिसिस ने रिजल्ट बोल दिया उसे, एनालिसिस हो गई भाई। क्या हुआ, उसको फांसी दे दी बंटी को, और बबली रानी को लेके भाग गया उसी समय। और राजा मेरे ऊपर नाराज हो गया, तूने एनालिसिस कैसे कर दिया ऐसा। मैंने कहा भाई मैंने क्या कर दिया, तुमने डेटा दिया था, मैंने कर दिया, गुस्सा क्यों हो रहे। अब इसमें क्या हुआ, अब आपको बताना है कि जो डिसीजन एरर है ना, वो अल्फा और बीटा एरर होती है स्टैटिस्टिक्स में। तो राजा ने दो मिस्टेक कर दिया, एक को तो मार दिया और दूसरा लेके भाग गया, उसको पता ही नहीं लगा कि कौन किसका संबंध है, रिसर्च ऐसी कर ली। अब अल्फा एरर कौन सी थी, बंटी थी या बबली? बीटा एरर कौन सी थी उसकी, राजा की, बंटी या बबली? और जो मेरे को डांट रहा था वो किस लिए डांट रहा था, मैं क्या सही था वो डांटना उसका? आपको ये जवाब मिल जाएंगे इसके अंदर, फिर उसके बाद मैं पूछता हूं, पहले मैं अपनी बात करता हूं आपसे, ठीक है? ओके, let us start statistically to define these errors. There are two jars, these are opaque jars, okay, and black and white beads are there. Now my motto is that whether distribution of beads in both the jar is equal or not. Black and white, okay. So I put one hand in this first jar and second hand in this, and 10 beads came into my hands. 5 black, 5 white. 5 black and 5 white. Do you think the distribution is same in both the jar? Can you say? Okay. Then next time I did, mix them, and next time I did, then now distribution comes in the hands 7, 3, 3, 7. Can you say they are different? Very difficult. So for you, now as a statistician, there are 4 possibilities and you have to segregate them. See how much problems for the statistician. You have to decide. So now, first possibility is this: it is possible that in reality there is no difference in distribution of beads between jar A and jar B. And by sample also we concluded the same. There is no problem. The distribution is same, and by sample also we did same. And why this problem comes in research? Because we deal with the sample, not the population. If there is population and we are doing the statistic, there is no error. What is coming, it is true. Because of sample, all things comes into picture. And you cannot do one population research because it is huge. Resources are not. And sometimes if you think that no, you can do, for example, diabetes. If you take all the data in the whole country, can you do? No. The things will change in between also. So that's why, for the particular point of time, you want to say something about a particular disease, you have to do the sample only, sample research. Okay. Now, second is, it is possible that in reality there is no difference. In reality, there is no difference in distribution of beads, but we concluded on the basis of sample that there is difference. So in reality there is no difference, but we concluded on behalf of sample it is difference, that is called alpha error. There is no difference, and we say that it is by sample. Third is, it is possible in reality there is difference in distribution of beads, but we concluded on the basis of the sample that there is no difference. Although in reality there is difference, but we conclude that is called beta error. And it is possible in reality there is difference, and we also concluded as a difference. So first and fourth, there is no problem. The problem in between, by sample you are saying there is difference, but it is not really difference, then it is a problem. And first is there really no difference, and you are saying with the difference. So alpha and beta. Okay, you got my point? Here it is the crux is, if there is no difference, by sample you are saying difference, it is alpha. There is difference, by sample you are saying no difference, it is beta. And the more clear it is this. No, I will not tell about this now here. A healthy person, because it is you are the clinicians and medical fraternity, a healthy person diagnosed diseased. I mean, आप तो healthy है, आपको क्या by test you can make out that no, he is diseased. Then ये alpha error. which is very dangerous. And beta, you are not healthy, but test says it is healthy. That is beta. Okay? So, if beta, that's why we take alpha 5%, because we don't want to take chance. If healthy person is treated, what will happen? If not healthy, is not diagnosed as a disease, then he will come again to the hospital, no problem. So 80%, 20% for beta, and alpha is 5%. Confidence, 95% we take. The 95%, the person should not have the disease if he is not having the disease. So 25%, 5% plus 20, 25% sample size we reduce or we save from the population for the sample, and we conclude 100% for the population. That is the logic behind that alpha and beta. Now, the alpha is false positive. You see probability of subject with positive test who will not have the disease. So here you will see not normal, normal by the gold standard. Okay? In real. And by fecal occult blood test, not normal, not normal. And the not normal, but in reality it is normal. So 180 false positive. You are clear? 180 false positive out of 2000. Normal are 2000 total, and out of that 180 sample says it is not normal. It is alpha error. So 180 by 2000 is 9% sample saying alpha error. Okay, type 1 error we call it. So 9% it is. 180 divided by 2000. False positive divided by total. Negatives. Now false negative beta error. Probability of subject with negative test who will have the disease beta error. So here false negative is 10. Test says it's normal, but in reality it is not normal. Okay. So 10 by 30 total not normal. It is 33%. Did you get the idea that alpha error, how to calculate, how to do, okay? What is this alpha and beta? Because it is very crucial. If you understand that, definitely you are reducing your research from these errors. Now, this is very simple if the categorical data is there. Yes or no. Disease is positive, negative. Very simple. But if it is continuous data and you want to know what is the alpha error in that, very difficult. We will tell about that also. If distributions are totally different to each other, the red one is unhealthy subjects and it is healthy subject. The distribution is different totally. You can say this is unhealthy, this is healthy. No problem. But problem comes in this gray area. See yellow and blue. So this is healthy. The distribution you are saying that the blue area is going for the unhealthy persons. And the unhealthy persons distribution comes into the normal persons. So this is the gray area we have to decide, the beta and alpha error. We have to segregate, we have to compromise whatsoever we have to do. This is for the continuous variable. So let us take an example for alpha error and beta error, how to calculate them. Let us see first normal curve. What is the normal curve? Okay. So on admission to hospital, patients are routinely weighed. You are asked to summarize the weights of 50 male patients who are admitted in your ward over a period of time. The weights are like that: 75, 67, so and so. Now this is the curve. Mean is 80.24 and standard deviation 8.4. If I calculate the Z score, then Z should be 0, mean should be 0, standard deviation will be 1. Then it is normal curve. Okay. And why we calculate the Z score? Because we want 1 unit for comparison to another group. So standard deviation this side, standard deviation this side. If mean standard deviation for both the groups are there, then you cannot compare which one is more or less because of variation. So we compare the two groups on the variation. Now, if it is perfectly normal curve by Fishers, this is derived by the Fishers, and you know that if Z is scored there, Z mean will be 0, the mean will be 0, and standard deviation will be 1. If I calculate the Z score, mean minus number of the x divided by standard deviation. X is the distribution of the function. No need to understand, but what I want to say, we talk about the 5% and 95%. 5% we say that it may be outliers and it may be the deceased person, or rest is that. So we calculate the probability that if it is less than 0.05, we reject the null hypothesis that there is difference or not difference. That is the concept behind it. So calculate alpha error. Cholesterol level of healthy subjects are normally distributed within mean 180 and standard deviation 20. This is the normal distribution of the cholesterol levels. If the subject with cholesterol level over 225, if some person comes to you and its cholesterol level is 225 and it is diagnosed unhealthy, what is the probability of a type error? I mean, what is the alpha here? The odd probability of being healthy. Because you discarded that, it may be unhealthy. So what is the probability of a healthy? I mean, alpha error. So mu is equal to mu 1, I mean, equally we have to reject the null hypothesis, and the alternative hypothesis, there is no difference. There is difference between them. So assuming they are equally healthy, then calculate the Z score. The 225 is the x value minus mean divided by 20 standard deviation. The Z score comes 2.25. If you go for 2.25 here, you will find that this is not. The Z score is, probability area will be 0.0122. So probability is 1%, 1.2% probability that this fellow will be healthy. Very rare. So less than 0.05, so we reject the null hypothesis that this person is not healthy, who is having 225 cholesterol level. So it is simple. Yeah. Again, this is another example. Sometimes what happens, the alpha error is given. You have been asked that what is the level of the cholesterol. We can say predisposed of the diseased person. Cholesterol level of healthy subject are normally distributed within mean 180 and the standard deviation 20. At the level exceed of 180 should subject the diagnosis are not healthy. If type 1 error is 2%. So if type error is there, then you can make out what will be the level of that cholesterol level for that subjects. You can the same, the equation is same, only you have to change the Z score to 0.05 because 2% is the corresponding value of the Z score is 2.025. Sorry. I am not going to calculate this, but you are agree or so I am fast or it is okay? But this is the equation, this is the equation where this value 2.05 is given by this chart, the probability area. And you can make out easily from that. It is, I have marked that where you have to go and where. So 2 and 0.5 is here. So this is the probability. The 9.9878. This is the, I mean, nearby the 2%. Okay. 1 minus 0.9878. So it is 2% more than that, little bit. Okay. So alpha error, you got. What is alpha error? I want to give the message that if a healthy person diagnosed as unhealthy, it is alpha error. And we take at 5% because 95% confident we should be. A healthy person should not be treated. And now beta error. How to calculate the beta error? Subject predictive heart disease. Now we are talking about the diseased person. Okay? We are talking about the diseased person. There we talked for alpha, healthy person. This is the difference. The subject predicted to heart disease have a mean cholesterol level 300 and standard deviation 30. But only subject with cholesterol level over 225 are diagnosed as predisposed to heart disease. What is the probability of type 2 error, beta error, or probability of not being healthy? Okay. So again the same, Z square same, everything is same because area under the curve is same, Z score will be same, probability will be same. So only the formula you have to type, and now the things will come in negative. That's all. So absolute, we have to take absolute value, no negative, no positive. So now here the Z square comes, Z value comes 2.25, which it corresponds to tail area 0.0062. The probability of type 2 error, very rare, very little. If 225 values is there, the chance of being disease is very rare. Okay? Clear? So he will be what? Healthy or unhealthy? Probability of being unhealthy is how much? So it is healthy. Similarly, what cholesterol level you diagnose? Subject as predisposed to heart disease. If you want probability 1% corresponding, Z score is minus 2.33. You just put in that. So 230 level will come. So it will be the probability, of beta error. Just remember, because calculation can be done easily by computer, just remember, if person is healthy, you diagnose it as unhealthy, is the alpha error. If person is unhealthy and you are saying by test it is healthy, it is beta error. Simple, huh? Okay. Now this is truly difference, beta error fixed at 20%. So I will not go to go further, but this is the by picture you can make out the question what we have solved by Z values and this thing. It is like that. Now, so my story starts. 3 things राजा ने किया था, 3, एक उसको 2 एरर हो गया था उससे, एक तो बंटी को फांसी दे दी, बबली लेके भाग गया और मेरे ऊपर गुस्सा हो गया क्योंकि मैंने एनालिसिस किया था। तो अब ये बताओ, 2 तो हमने सॉल्व कर दी एरर, तो बंटी कौन सी एरर था और बबली कौन सी एरर कर दी उसने? राजा की अल्फा बीटा एरर का किया उन्होंने, तो बंटी कौन सी एरर बना और बबली कौन सी एरर बना राजा का? है अल्फा किसके लिए और बीटा? वेरी गुड, दैट मीन्स व्हाट आई हैव टॉट इट इज ओके, आई एम ओके। ठीक है ना भाई, बंटी को मार दिया तो इनोसेंट था, तो बबली वो जो डिसीज मीन्स कल्पेट था वो लेके भाग गया, वो बीटा एरर हो गया। इट इज क्लियर नाउ, अल्फा बीटा बहुत प्रॉब्लम होती है। सारे लोग प्रोबेबिलिटी निकालते हैं कि पी वैल्यू निकालते हैं, लेकिन पी वैल्यू समझ में नहीं आती कि क्यों निकलवाते हैं। ठीक है, तो ये है। नाउ ही स्कोल्ड मी आल्सो, तो मैंने उसको बराबर दिया, क्योंकि भाई मेरे को क्यों गुस्सा कर रहे हो, तुमने एनालिसिस करा, मैंने कर दी, लेकिन तुमने डेटा कैसे कलेक्ट किया। नाउ द सैंपल एरर कम्स। ओके, if you do conduct the research and samples, error should not occur. If it is there, then bias result will come, random error may come, and confounder will come. So in sample, 3 errors can come. Two decision error and 3 sample error. So total statistical errors are 5. So what is bias? You are very biased for this topic or this and that. Okay. If you go for English, it is very difficult to understand. If you speak in Hindi, this bias, what is bias? Hindi word for bias? Huh? Because English we know. Yeah, I will tell later on. Okay. So bias, I mean वैधता ना हो, जिसमें जिसकी वैधता ना हो वो बायस होता है। अवैधता बोल सकते हैं इसको। रैंडम चांस, कन्फाउंडर मीन्स गुमराह करना, ऐसा रिजल्ट जो गुमराह करे वो कंफाउंडिंग होता है, कंफ्यूजिंग। इफ यू इंटरप्रेट द रिजल्ट दैट सैंपल रिजल्ट कंफ्यूजिंग यू, दैट इज कॉल्ड कंफाउंडर। और बाई चांस इट हैपेंस, इट इज रैंडम एरर। एंड बायस इन अवैधता, मतलब जिसकी वैधता है ही नहीं। अब फॉर एग्जाम्पल, अगर आप किताबों से समझोगे इनको तो बहुत डिफिकल्ट है। अब मैं थोड़ा सा अपने हिंदी में समझाता हूँ आपको, तो आपको समझ में आ जाएगी और आप यू कैन मेक आउट व्हेन इट इज रिकॉर्ड एंड वेदर इट इज बायस इज देयर और नॉट। बायस हमेशा बाहर से आते हैं, गलती जो एरर होती है ना रिसर्च में, सैंपल में, वो बाहर से होती है। और ये इसको रिसर्च का कैंसर बोलते हैं। इट इज कैंसर, रिसर्च इन कैंसर। ओके, अब बाहर से क्या क्या हो सकता है जब तुम सैंपल कलेक्ट कर रहे होगे, तो उसमें प्रॉब्लम क्या क्या आ सकती है, उसको सॉल्व करिए। आप कौन कौन सा वेरिएबल कलेक्ट करना है आपने, उसमें कैसे उनको मेजर करना है, मेजरमेंट उस वेरिएबल के स्टैंडर्ड है या नहीं है। तो ये वैलिडिटी की जो दूसरा बोलते हैं वैधता, वैलिडिटी है, एक्चुअल में वैलिडिटी है वो इंग्लिश में, तो उसको अफेक्ट करती है। जब वैलिडिटी रिजल्ट रहेंगे तो व्हाट इज द यूज ऑफ डूइंग द रिसर्च। तो इसमें रिसर्च डिजाइन एप्रोप्रिएट होना चाहिए, रैंडम सिलेक्शन होना चाहिए और वेरिएबल मेजरमेंट एप्रोप्रिएट होना चाहिए। तो आपका बायसनेस कम हो जाएगी रिजल्ट उसमें, स्टडी में। और ये कैंसर अगर पहले नहीं समझे ना, पहले नहीं किया, तो आपको ये बिल्कुल बर्बाद कर देगा रिसर्च। वही राजा वाला हिसाब हो जाएगा। तो आपको राजा नहीं बनना, आपको रिसर्चर बनना है। उसके लिए आपको वैलिडिटी ऑफ रिसर्च देखनी होगी कि बायस तो नहीं है कहीं। तो थॉरोली रिव्यू ऑफ लिटरेचर करिए, हाउ दे हैव मेजर्ड द वेरिएबल्स एंड व्हाट इज द परफेक्ट मेथड, व्हाट विल बी द सैंपलिंग फ्रेम, कहां से सब्जेक्ट लेने तुमने। राजा ने कहा, वो गया कहां था, बात तो महल की थी, रिसर्च तो महल की थी और वो शिकार करने गए, वहां डेटा कलेक्ट कर रहा है, बताइए। तो आप ऐसा मत करिए। जो सब्जेक्ट, जो तुम टॉपिक ले रहे हो, उसी को पॉपुलेशन उसी के लिए होनी चाहिए सैंपल। It should be very much, it is like that you are doing conducting research in hospital and talking about the community. It is not possible. Result will be biased. Okay? तो आप सैम्पलिंग फ्रेम देखिए। फिर आता है रैंडम नंबर्स। रैंडम नंबर क्या होता है? रैंडम एरर क्या होती है? सोचिए एक वेइंग मशीन है आपके पास, और जनरली घर में हर एक में होती है। आप उसको कितना भी कैलिब्रेट कर लो, 10 बार उसके ऊपर खड़े हो जाओ उसी समय, कभी अप कभी डाउन, कभी अप वेट देगी आपका। तो ये अप डाउन है, वो रैंडम एरर है। और ये रैंडम एरर एप्रोप्रिएट सैंपल साइज से खत्म हो जाती है। जब एप्रोप्रिएट सैंपल साइज होगा, कुछ का तो ज्यादा होगा, कुछ का कम होगा, एवरेज लोगे तो परफेक्ट हो जाएगा एस्टिमेशन। तो रैंडम एरर भी आप निकाल सकते हैं। और कंफाउंडिंग ऐसा है कि इसको कभी भी एनालिसिस में निकाल सकते हैं, लेकिन बायस को कभी नहीं चेंज कर सकते आप। एक बार इंसर्ट हो गया, फॉर एग्जांपल बायस, लेट अस से वेइंग मशीन, अगेन दैट एग्जांपल, आपने थोड़ा टिल्ट कर दिया उसको और सबका मेजरमेंट ले लिया और 1 किलो सबको ज्यादा दे रहा है। भाई मेरा वजन 70 किलो तो 71 दे रहा है, आपका 72 दे रहा है, और किसी का कम दिया, मतलब 1 किलो डिफरेंस दे रहा है। तो बायस कितना हुआ? 1 kg। आप एस्टिमेट लोगे तो बायस आएगा, रिजल्ट 1 kg बायस आएगा नहीं। तो ये देखिए आप, तो आप एस्टिमेट जो कर रहे हैं एक्यूरेट नहीं कर पाएंगे। तो वैलिडिटी, वैधता वो खत्म हो जाएगी आपकी। क्या कुछ रहे हो और रिजल्ट कुछ और कह रहे हैं आप, कुछ मतलब रिजल्ट एनालिसिस कुछ और कर रहे हो और रिजल्ट कुछ और आते हैं, वो गलत है। तो बायस सिस्टमैटिक एरर, एरर इन सिस्टम प्रोसीजर, दैट इज कॉल्ड बायस। ओके, तो सिंपल, इट इज ओके। एंड रैंडम एरर बाय चांस, एंड यू कैन accurate it by the sample size. Now confounding, तो गुमराह करते हैं, जो रिजल्ट गुमराह करें। इंग्लिश में देखोगे तो उसको इंटरप्रिटेबल एरर। नो, it is not interpretable error. You are interpreting the result. Okay? Whatever result are coming, it is, you are interpreting. So where is the interpretation result? But it is गुमराह करने वाली result. ऐसा आउटकम जो गुमराह करे। एक एग्जांपल देता हूं, चाइना में 2004 में एक रिसर्च हो गया, CHD एंड कॉफी। The researcher conducted the research and they totally ignored the age variable into the multivariate analysis. What happened? They got the coffee is associated with the CHD, and they didn't took the age, and age is related to coffee as well as CHD. As age increases, both the consumption of the coffee and the chance of the CHD increases. So the age is the confounder. Okay, here age is the confounder because it is confusing. So, but they did the later on they found something, because reviewers did that you have the confounder age and you have not incorporated in the multivariate analysis. That's why the result is the coffee is associated with the CHD. तो आपको बहुत ध्यान रखना है इस बात का। आपने वेरिएबल कलेक्ट कर लिए, और कुछ को मल्टीवेरिएट में लगा दिया, किसी को नहीं लगाया, ऐसे नहीं चलता। तो कंफाउंडिंग को अगर करेक्शन कर सकते हैं तो किससे? स्ट्रेटिफाई एनालिसिस करो या फिर मल्टीवेरिएट एनालिसिस करो, सारे वेरिएबल्स को डालो जो भी इंपॉर्टेंट है। Now I will little bit, because what I have discussed with this bias, random and confounder, already I have summarized. What is this? But let us, what the researcher or the book people says, I will tell you. Bias can cause a perceived association which is directly opposed to the true association. The time is okay, or we are in time? or everybody is bored? No, I will conclude very fast because, this all I have given. I have made that all the error, 5 error clear. If there is any problem, you can ask. I will give you 5 minutes or 10 minutes to ask the question. I will complete this because whatever I have told, it is already conveyed the message. So, for example, prior to 1998, multiple observation studies demonstrated that hormone replacement therapy decreased the risk of heart disease among post-menopausal women. However, more recent studies rigorously designed to minimize bias have found the opposite effect. So, see how bias can play in part. Just opposite the result. Now, what is the difference between bias and random? These are the differences you can read out. Undetermined studies were, see, the bias affect the validity, vaidata, or random within. So, random accuracy को हिंदी में क्या कहेंगे? वैधता हो गया, वैलिडिटी अफेक्ट करता है बायस. वैलिडिटी, व्हाट डू यू मीन बाय वैलिडिटी? देखिए, मैं एक रिसर्च करना चाहता हूं. लेट अस से knowledge on organ donation of this group. How much knowledge you people are having on the organ donation? Knowledge is the latent variable, you cannot measure directly. Okay? So what I will prepare? Items. Your age, your gender, how much education you are having, do you have organ donation you have done or not? Or somebody you know who has done organ donation, for what they have done. So many list I will prepare. Then I can assess that. If I just prepared and make that analysis and prepare this, and if it is not validated and the questionnaire is not up to the mark to measure the knowledge of organ donation, it is useless. So there is process in English as statistics, that how you are going to see the validity of that questionnaire. So means I want to say that how you are going to measure whether this measure, the way of measuring is good or not. The preparing question to know the knowledge about the organization is appropriate or not. That is called validity. You got my point? So what you are going to do the research, it is for that purpose or not? You are going to solve this problem or not? That is the validity. And random error, accuracy, suddhata, how much accuracy it is having. So, but it is within, so you can rectify by the appropriate sample size. Bias creeps into study in measurement from outside. भाई मेजर कर रहे हो आउटसाइड, या किसी का इंटरव्यू ले रहे हो आउटसाइड ले रहे हो. ओके, सो दैट इज it comes in from the outside and it keeps in measurement within the study. I mean, you are taking measurement within study, it is variation is there. It is present to study which does not have antidote and can be avoided only. No way to survive the research. It is like cold, normal, routine, and treatable if not curable. It is just like a cold, the random error. You increase the sample size, make the appropriate, it will go. It is artifact. I mean, the bias can be only artifact. So, be neutral while conducting the research. What is the methodology? You just follow that. Don't apply your own brain. So these are the some things, I mean, pre-tax bias, remedy, this and that. But what is the bias? You should know that. Bias means what is the validity. If it is not valid, then the research is not valid for particular topic, that means biasness will be there. If it is, the sample size is not appropriate, random error will be there. Interpretation of the result should be in the follow-up review of literature. So for example, CHD with coffee. So these are the things you have to keep in mind. Some people say that challenging bias, selection bias, so this all are bias because of outside procedure. You should do the procedure rightly with the methods, that's all. These are remedies. This is nothing. So now summary of systematic error. Bias is systematic and unexpected variation in research findings. Bias creeps in the study from outside. It is impossible to correct and only can avoid it by careful forethought of the studies, by research planning properly, by seeing the finer formula. Research designing, appropriate research design should be there. Research sampling, the sampling frame, appropriate population should be selected, and measurement of research variables should be appropriate. Then randomization also required. Example of bias: selecting the poorest people to study the effect of anti-poverty program. You know, population is different. People who drop out may be the ones who needed it most. I mean, selecting the lowest functioning mentality illness people or something like that. Measurement, use of invalid measurement, sampling, targeting sample which may not be suitable to representing population. That is what I have already told. You have to keep in the mind. So how to control the biases means randomization. Selection of appropriate research design, selection of appropriate tools, measurement and methods and procedure, selection of appropriate sampling methods. Summary of random errors. It is random variation caused by unpredictable fluctuation in the reading of a measurement apparatus. Okay? Like the weighing machine. It is hidden error in the apparatus used for measurement and occurs when a quantity repeatedly measures gives inconsistent values. Every weighing machine can give this or other instrument. Statistical analysis is key feature to determine whether the findings of a study are due to chance or real. Adequate sample size is required to avoid this error. Random error, plainly you can avoid by the appropriate sample size. The confounder, this is the same example I have given, the age, coffee, CHD. That age is confounder here because age is related to the coffee and CHD also. Okay. And I have proved by this example that how now if you see the coffee odds ratio is 1.95. I mean 2 times risk associated, coffee is associated more for the CHD cases. Now, if I do the stratified analysis, less than 45 and more than 45 for the age, it is odds ratio 4 for the CHD. Now, if I go for less than 40 years, coffee yes or no, and then if I got the odds ratio, it is 1:1. So that means coffee is not associated with the CHD, only the age. That's why age is confounder, and we have to adjust in the multivariate analysis, so real rate will come. How to control confounders? गुमराह करने वाला क्या? Restriction of subject according to potential confounders. Random allocation of subject to study groups to attempt to even out unknown confounders. Matching subject on potential confounder, thus assuring even distribution between among study groups. In data analysis, how you can remove the confounders? By stratified analysis and multivariate analysis. So thumb rule is what? Involvement of statistician when research begins till end of research planning, designing, whatsoever. This is the thumb rule, although you should know that. but involvement of the statistician most important for you, for your research. Take home message. Randomization and matching are essential components to remove bias and confounders. Appropriate sample size is essential to remove random errors. Research designs provide clue to calculate sample size. Research designs are essential to make good research answer from the research question. Research designs pave the way for statistical techniques. Now, root of success. यो माम पश्यति सर्वत्र सर्वं च मयि पश्यति तस्य अहं न प्रणश्यामि सच में न प्रशस्यति. Srimad Bhagavad Gita chapter 6 verses 30. What is the meaning of that? It is rule of thumb for success. Lord Krishna says to Arjuna, जो मेरे को सभी जगह देखता है और सब में देखता है उसके लिए मैं अदृश्य नहीं हूं और वो मेरे लिए अदृश्य नहीं है. तो इसीलिए काउंट इन द सब्जेक्ट काउंट्स इन यू. आप सब्जेक्ट को बन जाओ, सब्जेक्ट तुम्हारा हो जाएगा. पढ़ो उसको, गो थ्रू इट. सो भगवत गीता गिव्स द सक्सेस. नथिंग इज इम्पॉसिबल इन दिस वर्ल्ड. Be on the subject, subject will be for you. Thank you. You can ask now. Any doubt? तो नहीं, अभी मेरा क्वेश्चन खत्म नहीं हुआ. ये मेरे को राजा ने डांटा था, सही डांटा कि नहीं? मैंने उसको खरी खरी सुनाई थी, सैंपल एरर्स. तो क्या राजा सही था? अरे भाई, उसने सैंपल कहां से लिया? शिकार करने गया, वहां से लिया. और कहां की बात हो रही थी? महल की. तो सैंपलिंग एरर कर दी ना उसने. और उसने पूछा किससे? चमचों से. अरे रैंडम तो एक ही लिया नहीं. वो आ गया, मैं राजा हूं भाई, अब बता इन दोनों में से कौन है. ना उसको मालूम, जो सब्जेक्ट था उसको मालूम ही नहीं है कि बात क्या, क्यों पूछ रहा है ये. और एनालिसिस तो मैंने कर, जो आएगा वही रिजल्ट आएगा. तो उसमें बायस, रैंडम एंड कन्फाउंडर्स तीनों एरर थी राजा की. उसने कोई सैंपलिंग फ्रेम नहीं बनाया था, फिजिबिलिटी नहीं देखी थी उसने ना. टॉपिक की फिजिबिलिटी तो देखो कि टॉपिक करने लायक है कि नहीं. रिसर्च फाइनल फॉर्मूला भी नहीं लगाया और वो रिसर्च करने चला गया है. तो आपको भी ऐसे नहीं करना चाहिए. बी केयरफुल अबाउट दैट. व्हेन यू आर गोइंग फॉर रिसर्च, डेफिनेटली यू गो फॉर द स्टेप्स व्हाट आई हैव टोल्ड. ओके, सो आई वाज आल्सो नॉट रॉन्ग, ओनली किंग वाज द रॉन्ग. ओके, थैंक यू वेरी मच. यस, नाउ आई एम रेडी फॉर क्वेश्चन. कोई राजा बनना चाहता है? कोई नहीं. नहीं, तुम रिसर्चर बनो, पूछो.
Thank you, sir, for briefly explaining about the research process, data and statistical errors. In statistical error also, I also learned it today. We say types of errors. He said it as decision errors. And we say bias, and he called it as sample errors. These are two different things which I also learned today. Thank you, sir, for your detailed lecture. So we have tea outside for you. So please take tea. Thank you.